Hey everyone, this is Mr. Ahlers. I'm really sorry I'm not here today. I'm feeling a little sick, but I have the notes for you all. We're going to talk about the shortest distance problems. You're going to do 6-68 and 6-70. So for 6-68, Laura needs your help. She needs to order expensive wire to connect her sound system to build her speakers and would like you to help save her money. She plans on placing her sound system somewhere in a cabinet that's 8 feet wide. Boom. Speaker A is located 6 feet above one end of the cabinet, and speaker B is 4 feet above. She'll need a wire to connect the sound system A and B to connect it to speaker B. Where should she place her sound system so that she needs the least amount of wire? So essentially, she wants to put this value, sound system C, such that this and this is minimized. So I'll call this X, and then this is 8 minus X. And I'll read all this picture for us down here. This is 6, this is 4. This is X, and this is 8 minus X. A, C, and B. AC is equal to AC squared plus 6 squared plus X squared. So it's AC is equal to the square root of 6 squared, which is 36, plus X squared. B and the BC is a little bit more annoying. Is equal to 8 minus X squared plus 4 squared, 16, plus, I think that is X squared minus 16X plus 64 equals BC squared, and then BC is equal to the square root of X squared minus 16X plus 80. And then we want to minimize this, so I'm going to add AC plus BC, and we want to look for a minimum. So square root of 36 plus X squared plus the square root of X squared minus 16X plus 80. So now I'm going to go to Desmos and graph those. So I have the square root of X squared X squared plus 36 plus the square root of X squared minus 16X minus 80. No, 16X plus 80. And then now we have a quadratic, and we look at that minimum, and that's our value. Thank you, Desmos, for sponsoring this video. So then, right there, we want X to be 4.8, and the amount of wire is equal to 12.806. I'm gonna skip this one. Bradley's enjoyed solving problem 6-80. Study Mr. Ahlers. For the first puzzle, Bradley decided to test what would happen on the side of a cylinder such as a soup can. Find points A and B labeled on the outside of the can with your team. Determine the shortest path from A to B on the surface. In other words, no part of the path can go inside the can. So most people would say, "Oh, I'd just go through the can," but it's kind of like you have to go around this like curved edge. But if you laid that whole soup can label like flat, it would just be a straight line. For B, what shape? If a shape is a cube, using a cube provided by your teacher, predict the path. Which path would be the shortest from opposite corner to the cube labeled C and D? Test your prediction. So I'd go up to the midpoint, and then I'd go from the midpoint to here. We're also going to do 71. Sorry, I keep adding problems. Cover the triangle on your paper. Then reflect one speaker so that the two speakers are connected with a straight line. So we have A prime, feet. And reflect one speaker so that when the two speakers are connected with a straight line, the line passes through the horizontal cabinet. I guess that isn't 6 feet. We don't know. We're going to draw a straight line from A to B. These are both. You draw it better. Questions: are these triangles congruent? They share a side, they have a right angle, and these two angles are congruent because it's how, like, when you bounce off these certain things, and these are vertical angles, so therefore they're congruent. So these triangles are congruent. So this is 6. I'll call this x. So you could do 6 over x equals 4 over x minus 8 minus x, and you get 4x equals 48 minus 6x, you get negative 48 equals negative 10x, x equals 4.8. When these speakers are connected with a straight line, two triangles are formed. How are these two triangles related? They're congruent because of angle, side angle. I may have gone through this pretty quickly, but we know that when we have something bounce off a wall, these angles are congruent, and then these two angles are vertical angles, so that's how we know they're congruent, so therefore these two angles are congruent. That's your notes. Your homework is below. Enjoy, and I'll hopefully see you all tomorrow.